Yes, students, we are going to talk about ammonia. Preparation of ammonia. Ammonia is prepared in the laboratory using ammonium salt and a base. Ammonium salt and a base. Ammonium is prepared in the laboratory using ammonium salt and a base. So, you should know that the reagents that are used to prepare ammonia should be dry. The reagents should be dry. These reagents should be dry. The reagents should be dry. The reason is if we use moist reagents, ammonia may dissolve. Ammonia will dissolve obviously when you are using moist reagents. That is the reason we are using dry reagents. So this is a sample setup to show how ammonia is prepared in the laboratory. So here is heat, and this is cotton calcium oxide, that is the method that shall be used to collect, and this is the mixture of calcium hydroxide. Here we have calcium hydroxide and ammonium chloride. Mixture of calcium hydroxide and ammonium chloride. Calcium hydroxide and ammonium chloride. So these are the two chemicals that you are going to react to prepare ammonia gas. So this is a drying tower. This is the ammonia that you are going to collect. Ammonia gas, and here we have a piece of red litmus paper. I know if you are genius enough, you know the function of red litmus paper there. This calcium oxide, I'm about to explain the function of that calcium oxide. The calcium oxide. So the flask containing the mixture is set in a slanting downward position. This flask should be set in a slanting downward position. Though I'm not good at drawing, but that is the key point that you need to take note. This flask should be set in a slanting downward position. You can be asked, why is it that the flask is set in slanting downward position? So this is the reason: to prevent water vapor which condenses on the cooler part of the aperture from running back into the flask. This flask is set in a slanting downward position so as to prevent the water vapor which condenses on the cooler part of the aperture from running back into the flask. When this water vapor that condenses on the cooler part of the aperture runs back into the flask might crack, and when the flask cracks, there will be no experiment that will take place. So ammonia turns moist litmus paper red, showing that it is alkaline. It turns moist litmus paper red. So this ammonia gas will turn this moist litmus paper red. It will turn moist litmus paper red, showing that it is alkaline. Okay, hope you have known the use of that red litmus paper. It is used to test the presence of that ammonia gas. Another thing that you need to know, ammonia gas can only be dried using calcium oxide. Ammonia gas can only be dried using this calcium oxide. Calcium oxide is the only drying agent that is responsible for drying ammonia. Calcium oxide is used here in this experiment as a drying agent. Calcium oxide is used as a drying agent. Calcium oxide, it is used as a drying agent. In that setup, it is used as a drying agent. So the equation, that is an obvious question that you can be asked in an exam, to write the equation that is going to take place in the flask. So the equation that you are going to write, you write the equation between calcium hydroxide and ammonium chloride to form calcium chloride, water and ammonia. You write the equation between calcium hydroxide plus ammonium chloride. We form calcium chloride plus water plus ammonia gas plus ammonia gas. Yes, this is the equation that is going to occur. This is the equation that is going to occur at this particular point. If you are asked to write the equation that is going to occur at the flask, this flask, or maybe they can say the equation that will occur at point X, this is the equation that is going to occur at point X. We write that equation and balance it. In balancing is a simple thing. It is taught in form 2. Here is 2. Then here is 2. Then here is 2. The equation is balanced. Another thing. So the reason why other drying agents such as concentrated sulfuric 6 acid or calcium chloride are not used to dry ammonia gas. If you use concentrated sulfuric 6 acid to dry ammonia gas, you are going to form a compound ammonium sulfate. So haitakuwa imetumika vizuri kama drying agent. That is the reason when you use calcium chloride, you are going to form a complex compound calcium chloride ammonium. That's the compound that you are going to form. So let us look at some of the physical properties of ammonia gas. Physical properties of ammonia gas. It has a pungent choking smell. When you inhale ammonia gas, it has some irritating or choking, you feel like some choking when you inhale this ammonia gas. Then it is colorless and it is very soluble in water. Hence a solution of ammonia is prepared using inverted funnel because it is very soluble in ammonia. It is very soluble in ammonia. So the chemical properties ammonia, let us look at the reaction with oxygen. Ammonia extinguishes a burning splint but burns with the yellow-brown flame in plentiful supply of oxygen to form nitrogen and water. So if ammonia it is put in a gas jar containing oxygen, it's going to form nitrogen gas and water. Number 2, the chemical property of ammonia, catalytic oxidation of ammonia. So in this catalytic oxidation of ammonia, you should take note because it is a common question that you can be asked either in paper 1 or paper 2. Ammonia is oxidized as follows in the presence of a red hot platinum catalyst. In a red hot platinum catalyst. In a red hot platinum catalyst. So that is the diagram showing how the catalytic oxidation of ammonia. Catalytic oxidation of ammonia. So here is oxygen. Oxygen is entering in. Then this is hot platinum wire. Hot platinum wire. Yes, that is hot platinum wire. Then concentrated ammonia solution. Concentrated ammonia solution. This is concentrated ammonia solution. So this is a simple diagram showing how catalytic oxidation of ammonia occurs. Some of the questions, possible questions that you can get in an exam. This is the first possible question that you can be asked. Write the equation showing how catalytic oxidation of ammonia occurs. You are going to write the equation between ammonia and oxygen to form nitrogen oxide and water. Then you balance the equation 4, 5, 4, 6. You must balance this equation for you to get 1 mark, or maybe an examiner, it will depend with the examiner, maybe can give you half a mark. So but you should know how to write that equation. Another thing, the observation that is going to be made in this symbol diagram. So I'm going to give you all the observations that are going to be made here. The first observation, red brown fumes will be formed at this point. Red brown fumes. Red brown fumes are going to be formed at that part. And then this hot platinum wire continues to glow. It will continue to glow. Continues to glow. Why? The hot platinum wire continues to glow because the reaction produces a lot of heat. Reaction produces a lot of heat. Another observation, the pH in this, this pH of this solution at the end of the experiment, the pH is going to be below 7. pH, it will be below 7. The pH will be below 7. The reason is the pH will be below 7 due to formation of nitric 5 acid at the end of the experiment. So at the end of the experiment, you will find that this solution will have formed nitric 5 acid, and nitric 5 acid is acidic. That's why the pH is going to be below 7. Those are the possible observations that are going to be made. And then another question, here comes another question that you can get in paper 1, mostly in paper 1. Apart from hot platinum wire, we can also use copper wire. Can also use copper wire. We can also use copper wire. We can also use copper wire. Then ammonia and oxygen react on the surface of the platinum wire, which act as a catalyst. The platinum wire acts as a catalyst. Platinum wire acts as a catalyst. So in this equation, we are going to put here platinum wire, which is going to act as a catalyst in this reaction. And a catalyst is a substance that speeds up the rate of a reaction. That is the function of platinum wire. That is the function of platinum wire. So I think that is all that you need to know from catalytic oxidation of ammonia. From catalytic oxidation of ammonia. From catalytic oxidation of ammonia. Then that marks the end of chemical properties of ammonia. As we shall be meeting next time, I'm going to talk about properties of aqueous ammonia. Properties of aqueous ammonia. Thank you. May God bless you.